So number 11 in the homework reads x to the 4 plus 9x cubed plus 23x squared plus 3x minus 36 equal to 0. All right? Now, for p, we're going to go to this number, 36. For q, we're going to go to this coefficient, which is a 1. So p over q, it's going to be all those numbers over 1. When the coefficient for q is a 1, I don't need you to list p and then q and then p over q. You could just do p over q right off the bat. So it's going to be plus or minus the factors of 36 and 9 and 12 and 18 and 36, right? So that's a pretty long list to be testing, okay? So what I said you could do is you could graph this, and when we graph it, we get x to the 4 plus 9x cubed. Oh, hang on. So x to the 4 plus 9x cubed plus 23x squared and plus 3x minus 36. Okay, so here's how the graph looks. I need to do zoom 6 here because I'm at a totally different window. All right. And you can see you've got like a whole selection of zeros there. All right. So it looks like x equals 1 might be a 0, but I always like to double check. So trace 1, enter, yep, x equals 1 is a 0. So I start with that one, and you need to show all of the different steps of the synthetic division, all right? So we're going to do x equals 1, and the coefficients here are going to be 1, 9, 23, 3, negative 36. So 1 comes down, 1, 10, 33, 36, 36, 0. Okay? All right, so here from the outside, I have x minus 1, and then the depressed polynomial, right? So here's one way to guide you. You see how, like, in the beginning, the degree was 4? Now it's going to be x cubed. So take a look at what I do. I just put, like, little x cubed, x squared, x, and then nothing. So that sort of, like, helps me, like, it guides me. So now my polynomial is x cubed plus 10x squared plus 33x plus 36. Okay, equals 0. Now, I need to factor this somehow. Now, this is a cubic term, x to the 3, and it's got 4 terms. 1, 2, 3, 4. Sometimes you can factor something like this by grouping. Not in this case. When you're out of options, you got to do the synthetic division again. So now I have to do synthetic division just on that depressed polynomial with the x cubed. All right, so I need to see if there are any other zeros that work for this. Okay, now if you go back to the graph, you see that we used x equals 1, but there are so many others, right? So it looks like negative 3. Let's see if negative 3 is one that we could use. So in trace mode, negative 3. Yep, that's a 0. So I put negative 3 here. 1, 10, 33, 36. Are we okay so far with what we're doing? All right, so the 1 comes down. Now we have 7. Negative 36. Okay, awesome, 0. Now, don't lose track. I had x minus 1 from before. What does this give me? X minus negative 3, which is going to be x plus 3, and then I have x squared plus 7x plus 12 equals 0. Now, this last depressed polynomial, x squared plus 7x plus 12, I can either factor it Or if I can't factor it, I have to figure out a different way of solving it. Quadratic, synthetic, blah, blah, blah. Luckily, I can factor that one. X plus 4, x plus 3. So now I get x equals 1, x equals negative 3, x equals negative 4, x equals negative 3. The negative 3 repeats. You don't have to write it twice though. So finally, our solution is just negative 4, negative 3, 1. You know when to stop? When you have factored everything, right? And there is no other way to factor. Like you end with x minus 1, x plus 3, x plus 4, x plus 3. You cannot factor any of these anymore, right? Yeah. So you stop. Yeah.
So I guess that when you have like when you're doing synthetic or what I'm when you do, let's say you do it with 1 on the outside, then it would be x minus 1, right?
Yeah.
But why? How do you know that?
It's always x minus that number.
Okay, so you just do that.
Yeah, because like if it's x minus 1 equals 0 and you solve it, you get x equals what? X equals 1. It should be that number 1. Oh. You get what I mean? It should go back and forth like smoothly. Okay. So with that, let's move on to the notes. This is where we had stopped. We're going to continue and we're going to talk about Descartes' rule of signs. Descartes was a French mathematician / philosopher. Descartes is the one who said, I think, therefore I am. He's also the one that gave us the x and y axis, you know, as a way to plot. So like if we talk about like the x and y axis, we call it a coordinate plane. We also call it a Cartesian coordinate plane for Descartes, okay, Cartesian coordinate plane. So he also came up with a rule of signs. And Descartes' rule of sign, it's actually really fun. It tells us the different possibilities of like how many positive and negative numbers you can have as solutions, right? So here you've got this little box, okay? And in here, it's talking about the number of variations of sign. And it's like so many words and words and words and words. I'm going to tell you how to do it. And we're just going to go right to it, okay? I feel like the most practical approach is the best when it comes to this, okay? So here's what you do. Eventually, we're going to make a chart of how many positive numbers there could be, how many negative, and how many imaginary. So for the positive case, what we do is you go down the terms of the polynomial and you see how many times there is a variation in the sign. How many times the term goes from positive to negative. So if you take a look here, the first term is positive x to the 4, then negative 3x cubed, right? And then it's negative 5x squared, and then it switches again to positive. So you have to count how many times does it switch between plus and minus. There is one switch here between positive x to the 4 and negative 3x cubed. Then there is another one here between negative and positive. Are we all okay with how we got those? So how many times is there a switch? Twice. Once you get that number, this time it's 2, it could be a 3, it could be a 5, it could be a whatever. Once you get that number, you always subtract 2. That's the Descartes rule part. You get that number and you do minus 2. Always minus 2. So now, if I take 2 and say minus 2, what do I get? Negative 0. So it's 2 or 0 because I subtracted minus 2. Now, had this number not been a 2, suppose it was a 3, it would have been 3 or 1 because you always subtract 2. What if it was a 5? It would have been 5 or 3 or 1. You keep subtracting 2 until you can no longer subtract 2. So if it was a 4, it would have been 4 or 2 or 0. Okay? Yeah. Okay, so you see how we counted how many times it changed sign?
Yeah.
And we got this number?
Mm-hmm.
You take that number and you do minus 2.
Oh, okay.
So in this case, 2 minus 2 is 0.
So either 2 or 0.
Yeah.
What about negative 2?
No, you only go.
It's only the number minus.
It's only number. Yeah. No, it's only the number minus 2.
Oh.
It's always minus 2. Okay. Now for the negative case, we have to look at f of negative x. Yeah. Okay. So now for f of negative x, I'm not gonna go through all the details, but basically, look at your polynomial. You see how you have exponents of 4, 3, 2, 1? If the exponent is even, 6, 4, 2, if the exponent is even, you leave that term the way it is. If the exponent is odd, you switch the sign. So, x to the 4, even, stays as is. X cubed, that's an odd, it's going to switch sign, plus 3x cubed, minus 5x squared, and then you switch the sign for the 2x, minus 2x, the 7 stays. So all the terms with an even exponent stay the way they are. All the terms with an odd exponent, 3 or 1, will switch sign. Yeah, you change the x because it's x to the 1, so you change it. Now we got to do that arrow business again. Now let's see in that case how many times there was a sign change. So there is one here where it goes from positive to minus, and then minus to plus. So for negative, we get 2 or 0. All right, so I'm just going to write those up here again. So positive 2 or 0, negative 2 or 0. Now I'm going to make my sign chart. Positive, negative, and imaginary. Okay, what I want to do now is, just like I did with the P's and the Q's, I want to do all the different pairing combinations. So I take the 2 and I match it with these, with the 2 or the 0. So it's 2, 2, 2, 0. And then I take the 0 and I match it with each. 0, 2, 0, 0. Okay, are we okay with how we did that? Again, think of them as, you know, League 1 and League 2, and everybody in League 1 has to play with everybody against everybody in League 2. Okay, so you just have to do like all the different combinations. It's like brackets in sports. Okay. Now, what's the degree of this function? 4. Each horizontal row now must add to 4. So in this slot at the very right, you have to put in whatever is missing to make each row equal to 4. So here I have 2 and 2. How much is missing from 4? None. So you put 0. In the second row, you have 2 and 0. How much is missing? 2. In the third row, how much is missing? 2. And then here, 4. Okay? So each row. Right. Now, one thing to watch out for, this imaginary column cannot have any odd numbers in there. It could only have even numbers, 0, 2, 4, 6, 8, because imaginary numbers always come in pairs. Okay? Column, so this column can only be even. All right? Okay. We're going to do one more of the same exact thing. Okay? So, for positive, let's see how many times this has a sign variation. Once here, 2 here, 3 there. Okay? Or what? 3 or 1. Okay, for the negative case, f of negative x is, okay, the even exponents stay as they are. The odd exponents will switch sign. Plus 3x squared plus x plus 18. Now how many sign variations are there? Just one. So it's 1 or nothing. It's just 1. Okay? If you cannot subtract any more 2's, you don't. So for positive, I have 3 or 1. For negative, I have 1. So when I make my chart, it's going to be actually a little bit simpler this time. Less combination. No. So in the first case, it's going to be 3 with the 1. And then the 1 with the 1. That's it. Okay. So what do we add for imaginary in the first row? 0, and then the second row, 2. What does this tell us? This function, okay, it has 4 zeros, right? There are two scenarios. It could either have 3 positive and 1 negative, or 1 positive, 1 negative, and 2 imaginary. So for example, this function, it's not possible for it to have like 3 negative zeros, okay, or 2 negative solutions, okay? Okay, so complex, speaking of imaginary numbers, complex numbers. Complex numbers are numbers that are a combination of real and imaginary. Okay, when you look at circuits, and when you look at like the resistance and the impedance and the capacitors, all of those values are real and imaginary numbers combined. Very interesting stuff. All right, so a lot of this is a lot of the things that you already know. Basically, this first theorem, fundamental theorem of algebra, is everything that you already know. It just says if a polynomial has a degree n, it has exactly n zeros. You know this already, okay? Factors. If you factor a polynomial completely, like we were doing up here, right? Here, where were we doing that? We just did it in the homework, right? So it's like x minus 1, x minus 3, x minus 4, x minus whatever. However many factors there are, that's how many zeros there are. Again, you guys already know this. So let's move on. This is a new word to like impress your friends the next time you're at a math party, this new term here. Irreducible quadratic factor. Okay? I know. So it's like my irreducible quadratic factor is better than your irreducible quadratic factor. This was the password at the last math party I went to. Irreducible quadratic factor. You can't just let anybody get in. Can't just let. Huh? Well, if you know the secret password, maybe you'll find out. Well, that was the last party. Okay. So
it's a kegger.
So the irreducible quadratic factor is, it's a term that's a quadratic, so it's like an x squared blah blah blah, and it's irreducible, so it can't be factored. So basically it's a quadratic that can't be factored. That's all it is. Okay, so here it says to write blah, blah, blah as a product of linear and irreducible quadratic factors. That is just code word for factor as much as you can. Okay? So this just means, this whole thing just means factor as much as possible. Okay? Okay. So, let's do P over Q. So for P, we're going to go to 24. Q, the coefficient is 1, and I'm going to save time. I'm not going to do P and then Q and then P over Q. Because the Q is 1, I'm just going to do P over Q right off the bat, and it's going to be plus or minus 1, 2, 3, 4, right? The factors of 24. Now, 24 happens to be one of my favorite numbers, by the way. Now you know. 12 and 24. Okay? Now, I just like the way it factors, like 1, 2, you know, it's like, it's, and like when I'm teaching like roots, it's like, it's such a good example, like the square root of 24, there's like so much because it factors into like 4 and 6 and then 2 and 2 and then 2 and 3, so it's like 2 comes out, but the 2 and 3, it's just, huh?
I was expecting you to say like Kobe Bryant's my favorite basketball
Oh, is he number 24?
He was.
Oh.
He just retired.
I just don't know anything about him.
Sorry to let you go that.
So Kobe, oops.
Where's X? Move to the second. Where is it? Oh, whoa. Thank you so much.
That's one of the purposes of this class.
We had a college counseling meeting today.
You did?
One of the things that like asked us was like, would you want to fix calculators?
No.
Fix or work
No,
with,
work
I
on
know.
Calculators.
Some of the students in my group had that question as well.
Why would they want to
Well, see, I mean, I work with them every day. Okay,
just have a career?
so look, there is a whole range here. You know what? Let's do a negative one this time. Let's see if negative 2 is a 0.
It is.
Yep, negative 2 is a 0. So let's do negative 2. So we're going to do negative 2. And we have 1, 1. Negative 13, negative 23, negative 14, negative 24. So 1 comes down, negative 2, negative 1, 2, negative 11, 22, negative 1, 2. Yeah. Okay? So here we go. Look at what we have here. I have x minus negative 2, and then the depressed polynomial is 1x to the 4 minus x cubed minus 11x squared minus x minus 12 equals 0. So now I need to factor this depressed polynomial. You have to do it again, but with another one of the zeros. So this is just minus x. All right, so for that, I go back to my graph, right? Now, I use negative 2. Let me use a different one. Let me use x equals 4 this time. 4 or negative 3? What do you guys want? Okay, 4. So here's 4. 1 minus 1 minus 11 minus 1 minus 12. 4, 1, 4, 3, 12, 1, 4, 3, 12, 0. But wait, before you do it again. So look, don't forget to carry everything over. X plus 2 from above, x minus 4 here. And here, this depressed polynomial this time is x cubed plus 3x squared plus x plus 3. Now look, when you get to a point where you have a cubic expression, x cubed, and you have 4 terms, 1, 2, 3, 4, your options are factor by grouping, or when all else fails, you can do the synthetic. It just so happens that you can factor by grouping here. So let's do that. Let's add a little variation. I'm going to split it up. So let's see. Let me just carry all these over. That's the method for factoring by grouping. You split it up vertically, like in the middle, right? You split it up in the middle. Now, from the left side, what can I factor out? An x squared, and I get x plus 3, plus another x plus 3. Now, because the second coefficient the second parenthesis doesn't have a coefficient, I just put in a 1, right? So it's plus 1x plus 3, right? So now I'm just going to transfer all this up here. I'm just copying it over here. So it's x plus 2, x minus 4. Now what I do is, the common term, I just write it here. And then what haven't I used? The x squared plus 1. Okay? Now, first parenthesis, factored. Second one, factored. Third, factored. Fourth one, x squared plus 1, I can no longer factor that one. It's a quadratic, but you cannot factor it.
You can split it up?
No.
No?
You said it equals 0?
We're just done. Because look at what it had asked us to do. Write kx as the product of linear and irreducible quadratic factors, which is code for factor as much as possible. We factored as much as possible. Look at the x squared plus 1. Is it a linear, quadratic, cubic, what? It's x squared, so it's quadratic. Can you factor it anymore? No. That's an irreducible quadratic factor, right? Came full circle, exactly. Okay? Yep.
Yes!
Oh, that's the we're trying to find.
For part A, that's all. It's just factor all the way. Part B, now it says list all the zeros. So let me just transfer that here. Yes, equal to 0. So, all of them. So x equals -2, x equals 4.
X equals 1 to x.
X equals -3. Now look, x squared plus 1 equals 0. X squared equals -1. You take a square root, not 1. X equals plus or minus I.
Oh, you can't have a negative.
Right? So those are all the solutions. How many solutions are there then? 4? 5. How many should there have been?
Most probably.
5. Okay? So there we go. At most 5 real zeros, but exactly 5 complex zeros. That's the fundamental theorem of calculus, of algebra. Okay? All right. So now, what if, like, this was a recording and now we're doing a rewind, right? So you know how like everything just like plays, like it just goes back in reverse? So what if we were to do that in reverse? The x minus 2 would become x plus 2. The x equals 4 would become x minus 4. And then we would have to multiply all this again. That's working backwards. That's what we're going to do for example 6. So for example 6, we're going to work backwards now. So the one thing we have to do is, how many of you guys have seen this term before?
complex conjugate.
Complex conjugate.
Oh, is that with eyes?
Complex conjugate is when you have a term with an I and then you switch the sign. So for example, if you have an I, it becomes negative I. If you have 3 minus I, 3 plus I, and so on. All imaginary numbers come in pairs. In this problem, you're given negative 3 and I as a solution. You yourself have to know to add its complex conjugate. So negative I. Okay? You can never have an odd number of i's. Always come in pairs. So now, if we're going to go backwards, the x minus 3 would be x minus negative 3, right? And then we have x minus I, x minus negative I. And all this is f of x. So let me just rewrite it. X plus 3, x minus I, x plus I. Now we're going to multiply all this. And I like to start with this combination where you have like a minus b, a plus b. So you remember when you have something like that, x minus 3, x plus 3, and you're multiplying, there is a shortcut. You square the first one, you square the last one, and you put a minus in the middle. Right? So that's what we're going to do here. So this is going to be, you square the first one, x squared. You square the last one, I squared, minus in the middle.
You keep the same
thing. So now, x plus 3. Okay, now here's another blast from the past. What's I squared equal to?
Isn't it like
Negative 1. So here we have x squared minus negative 1. What is that then? So let me write it up here. X plus 3.
that to get I, you need x squared plus 1.
Now we're going to multiply this, right? First, outer, inner, last. So first terms, x cubed. Outer terms, x. Inner terms, x squared. And then the last terms, 3.
And then you have to put it in order.
Yep. Look at you guys, experts. Okay? So see, we went back. Isn't that cool? And like if I was to do like synthetic division business on this, I would get like 3, negative 3 plus I minus I. That's so cool. Right? We just like put it back. It's like doing a puzzle, undoing it, and then do it again, and then undoing it. Yeah.
So how did in the first place, how did you get like the x minus negative 3 and how did you know what those were?
You're given this. Whenever you're given, you have to do x minus that number. X minus that number. X minus that number.
Oh, for I you always do that.
All right. How about we take it up a notch?
Oh, that's a little.
We're going to take it up a notch. We have negative 1. We have 2. We have 2 minus I. What do we have to add? 2 plus I. So, it's f of x equals x minus negative 1, x minus 2, x minus 2 minus I, x minus 2 plus I. Right? So it's always x minus the number, x minus the number, x minus the number. I know. So this is x plus 1. I missed the stuff. X minus 2. We're going to distribute the negatives here. X minus 2 plus I. X minus 2 minus I. Yeah.
Wait, what? Oh. And then can I just like they cancel.
No. Let's multiply the first two parentheses. X squared minus 2x plus x minus 2.
Wait, what do you say?
I foiled x plus 1, x minus 2. First, outer, inner, last. Uh-huh.
Oh.
This is why I don't like the term foil, because technically when you have like 3 terms like this, there is no first, outer, inner, last. Anyways, that's a whole other issue. I have issues with how we name things to make them simpler. Anyways, here's what we do. You have to divide and conquer. So, I'm going to take an x and give an x to everybody here. So, x squared minus 2x minus xi. Distributive property. Then, I take a minus 2 and give 1 to everybody. Minus 2. There's no other way to do it though. One thing, when you're doing this, like on a scale of 1 to 10, the level of complexity and difficulty when you're multiplying these parentheses isn't really that high up there. But when you're on Twitter and Instagram and Snapchat all at the same time and doing this, you're going to mess up on the negatives. So just close those for a bit and concentrate here. And then the I, we have to give an I to everybody. Plus xi minus 2i minus I squared. Now, eventually we're going to come up with a function. So the i's have to go away because you don't have a function like x squared plus ix. That's not a thing. So all the i's should somehow go away. If in this next step all of the i's don't go away, go back because you did a negative mistake somewhere or something. So right, those go away. The 2 i's will also go away.
What about I squared?
What about I squared? What's I squared?
It's like
I squared is -1.
I squared is -1, so this is minus -1, so it'll be +1 in the end. So I have x squared minus x minus 2 because I simplify it.
Wait, I squared is what?
Yes. Now, x squared minus 2x is minus 4x. Plus 4 plus 1 is a 5.
Oh, and then you do the same.
Now you do the same thing for that one. So here's what we're going to do. I'm going to race you to it. So we're going to distribute. We're going to distribute.
Okay.
Wait, is
When
the
should we
first,
start?
is the what you just did in
I'm gonna
purple
go
just the first in parentheses?
No, the first purple is the blue. This is the blue.
Wait, how?
Because minus 2x plus x is minus x. Your minus 2x plus x is just minus x. And then this is the second purple.
Oh, I see.
Because everything went over. I see, right? Okay. All right, I'm going to race you to it. Now you have too much of a head start.
No, come on.
What are we doing?
We're going to multiply this.
No, because when I race, forget about negatives and just the thing.
I'm done with that. Oh, yeah, I remember. But how do you take that stuff? Do you have to take that stuff? Because it's not an animal. Oh, I see what you do.
No.
Oops.
I don't like doing like this. What's 4x squared? Okay, done.
She's just distributing.
Finished.
All right, do we have this?
Not
Yes.
at all.
Yeah.
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 So we've been doing synthetic division with real numbers, right? Like outside, like we have a -3, a 4, a 5, whatever. It doesn't have to be a real number. It could be an imaginary number. So here it says to find all the complex zeros of this polynomial, given that 5i is a 0. So if 5i is a 0, what else is a solution? Negative 5i. So 5i and negative 5i. So what you do is this. You're going to do synthetic division with the 5i. Yeah, but now look, spread this out because things get a little, like you're going to have two terms.
Oh my god.
All right, so now 3 comes down, multiply with 5i, I get 15i. So here I have -5 plus 15i. Now we're going to multiply. 5i times -5 plus 15i. So that's -25i plus 125i squared. 75i squared, I'm so sorry.
Is there a way to do this on a calculator?
So you're going to have to show me the work.
Okay.
So 75i squared, what's I squared? -1. So it's -25i minus 75. Okay.
Why is it -75? Because I squared.
Yeah. So now I like to work on scratch paper so you don't mess things up like this. So I'm gonna erase along each step. So now we're gonna get -25i. -13 minus 75 is -88, right? So things are gonna get messy. So now we're gonna multiply that by 5i. So 5i times -25i minus 88.
How did you get? Oh, minus 125. What's the number 25i minus what?
88.
How'd you get 88?
Well, I added the 13 and the 75. Like,
Oh.
okay. So now, what's 5 times 88?
440.
Right? So it's going to be 440i. So that's positive 125 minus 440i. Because I squared is -1 and it was -120. Okay. So now 125 minus 65. So that's 60 minus 440i. And now we're going to multiply. Not always. So there are, I like to leave the good ones for you guys to do on your own. You know what I mean? So I picked the one with the big numbers here. But it's fine because we can do this. So 5i is 60 minus 440i. So here we're going to get 300i minus 440 times 5, 2200i squared. Yeah. So that's 300i plus 2200. So we get 300i. And when I multiply by 5i, I get -1500. So I get 0. Should I have gotten 0?
Yeah.
Why?
Because it should work.
Because
it said 5i.
it says 5i is a 0.
So now let's do it again with negative 5i.
Thank you so much. I like that attitude. Okay. So now negative 5i.
What? How did that go with 5i?
This is actually the cool part. Watch. Check out what happens here. Okay, so no, 3 comes down. 3 comes down. You multiply by negative 5i, so you get negative 15i. And what do you have left?
0.
Nope. Negative 5. You multiply by negative 5i. Now just be careful with the signs, please. So we're going to get positive 25i squared, which is negative
How'd you go from
That's
60
25i.
minus
25. Wait, I'm sorry. Hang on. Yeah. I'm sorry. Say it again.
How do you get from
Yeah.
How do you get from 60 to 300?
I multiplied.
Oh, sorry.
Okay, so here we get 25i, and they cancel, so I get negative 88. Now, multiply by negative 5i, so I get 88 times 5, 440i. So it's 60. Multiply by negative 5i, negative 300i, and it goes to 0. You see how they all go away? Isn't that cool? So now,
Oh, it's just the second part of the top one.
yeah. So now look, I started with x to the 5, synthetic division once, x to the 4, synthetic division twice, x to the 3rd.
Should we always do the positive?
So now it's x cubed, that's up to you. Okay? So now it says find all the zeros. So I have 3x cubed minus 5x squared. Well, let me write all of them. So it's x minus 5i, x plus 5i, 3x cubed minus 5x squared minus 88x plus 60.
Wait.
So,
Isn't it just 5i? 5i?
right, but then, like the factor is like x minus
Oh,
5i, x plus
yeah.
5. So how do we factor this?
So where did you get the other one?
Take off.
Oh, you can do what's it called?
Grouping.
Yeah.
Can you do grouping here?
No, we're done. How do you know if you can or can't?
If they're like common terms.
Yeah, if there is something that you could factor out from
You
both.
have to do it again.
You can factor out it too.
So you're done? We're done.
I mean, or do you have to synthetically divide?
You have to do synthetic division.
Oh.
Thanks, Dylan.
I love how you said this is itchy bitchy. This is not.
All right. So,
Yeah, I got no room.
it's okay. So what can we do here? Let's see. 3x cubed. All right, so 3x cubed
Wouldn't it be to the fourth? Oh, wait, no.
Oh, I see. Oh, yeah, okay, wouldn't it be x to the 4?
but we did do it twice.
Oh, okay.
88x plus 60. What number is that? 1, 2, 3, 4, 5?
Yeah. Right?
Yeah.
6. Okay? So let's do it with the 6.
I like no room.
So 3, 18. 13, right?
Yeah.
Hey, look, it's 0. So, x minus 5i, x plus 5i, x minus 6, 3x squared plus 13x minus 10 equals 0. How do I factor that little guy? Quadratic. Quadratic on that guy. This is like the mother of all problems. Negative 13 plus or minus the square root of 13 squared, which is what these days?
Wait, why do we have to
13
do
squared is 169.
Mm-hmm.
Actually, might have a hard time.
X equals 169 plus 120.
Wait, how did you get 6? One step up.
Oh my god.
Yeah, can we like sit down and just work this again?
So that's actually where, you know, it ends.
Oh.
How'd you get 6?
I graphed.
Wait, so dots is 0, and then the other zeros are 5 and negative.
Right. So the zeros, so all the zeros then are x equals plus or minus 5i, 6, and negative 13 plus or minus the square root of 289 over 6.
Oh, 6.
How many total zeros are there?
5.
2 from the imaginary, 2 from this, and 1 from that. So 5 total zeros. So now you can complete the rest of the homework, but please complete it as one assignment. So just keep adding to the one you had done for today.
Wait,